It's time for another amazing chemistry video with Mr. Stapleton, proudly sponsored by Farming Union Nice Coffee.
Okay, welcome to the next video on stoichiometry. In today's one, what we're going to be doing is actually looking at doing titration calculations. Okay, so I'm going to go through a 6-step process that I always use for whenever I'm trying to do a stoichiometry titration calculation. What you'll find in the exam is that they'll actually split these up into individual A, B, C, D, E. Okay, so you'll actually get marks for each of them as you go through. All right. So first thing I always do, and this is key. If you don't get this right, you can never get your calculations right. Okay, and that's a balanced equation. So if you are still having trouble writing your formulae, balancing your equations, please go back over those videos. Please go back over the worksheets. Practice, practice, practice. You need to nail that by the exam. Then what you do is you write down what you know. And what I mean by that is you find the values for your chemicals that you've got in the question. It'll be a volume, it'll be number of moles, it'll be mass, all right, anything like that. You write it down and I'll show you how to do that. Okay. Then you calculate N, number of moles, for what you know, all right, using one of these two equations. So either mass over molar mass, all right, or concentration times volume. Then calculate the mole ratio. All right, so the mole ratio is actually using the balanced equation. That's why the balanced equation is so key. All right, and I'll show you. You use the numbers out the front of your chemicals, and you put unknown over known. I'll show you that as well. Then calculate number of moles of your unknown. Now, if you don't know which one your unknown is, that's the one that you've only got one value for generally. Okay, and then to do that, you just times step 3 by step 4. Okay, and then answer the question. And so regardless of what chemicals you're using in your titration, follow these 6 steps, okay? Because the final one might ask you to calculate the mass, it might ask you to calculate concentration, it might ask you to calculate percentage weight per volume. It doesn't matter. If you follow these same steps, you've got everything you need to be able to do that final calculation. So keep that in mind. Hopefully you've written that down somewhere or got it off the other notes. Okay, so I'm going to move that to the side. I'm going to show you how we actually do a reasonably straightforward titration, all right, but one that will be able to help you hopefully as a basis for any other calculation that you're going to do. So what I'm going to do is I'm actually going to show a reaction between some sodium carbonate solution, okay, which is the standard solution that you'll make the first time you do some of this titration work, and we're just going to do it with hydrochloric acid, all right, and we need a balanced equation for this. Carbonate plus acid, if you don't know it, go back and look at the videos. Carbonate plus acid is a salt, which is sodium chloride, plus carbon dioxide plus water. All right, so in this titration we should observe some bubbling in our conical flask, okay, and that'll be one indication that we've got a reaction occurring. Okay, we need to balance it up. We need a 2 in front of that, okay, and a 2 in front of that to make our equation work. Now, let's say your standard solution, all right, is your sodium carbonate that you've made up, so that's going to be in your conical flask, and so you have taken, for that volume, you took 20.0 millilitres in your pipette, okay, and the concentration that you made up for that was 0.104 moles per litre, okay, so this is what I'm talking about, writing down what you know. Okay, you know the volume for the sodium carbonate because that's what you took up in your pipette and you used in your conical flask. You know the concentration because that's what you made up from your standard solution. Okay, you dissolved a certain amount of sodium carbonate into a volumetric flask, made it up, and you made that calculation. In an exam situation, they will give you a volume in the pipette and a concentration. Okay. Let's say that doing our titration, we had our hydrochloric acid in the burette. Okay, and we got an average titer value of 31.6 millilitres. That's our concordant titer value. And there's another video all about titration techniques and getting your average titers and what concordant titers are. So have a look at that one if you're not sure about it. That'll be coming out in a sec. All right. So what we've got here is 2 values for our sodium carbonate, 1 value for our hydrochloric acid. So what you can do is work out that this one we have 2 values for. I'm sorry, I'm going to get a different blue for that. Okay, we have 2 values for this. Okay, if you have 2 values, that makes it our known. Okay, what we have here is only 1 value. All right, that is our unknown. Because what we're trying to do in this calculation, or in this titration, what the point of this would be to determine the concentration of our hydrochloric acid. And because we've only got one value for that, that's our unknown, that's what we're trying to work out. So remember to keep that in mind because that's important. So we worked through those steps. First step was a balanced equation. Second step, writing down what you know. Third step, calculating number of moles for what you know. So a lot of people do it differently, but I actually like to use subscripts when I'm actually doing calculations. So I want you guys to get into the hang of that. So we want to calculate the number of moles of our sodium carbonate, Na2CO3, are known. Okay, so using our little triangle here, number of moles is concentration times volume. Okay, so that's why it's good to keep those little triangles nearby so you can remember. So our concentration up here is 0.104 and our volume is 0.0200. Okay, notice I've already done the conversion from milliliters to liters. Okay, really important that you do that. Okay, and so what we end up with for this one, if we do this calculation, is a value of 0.00208 moles. Okay, so that's the number of moles of our known. Next step we do is calculate the mole ratio. Okay, so that was step 3. Okay, that was step 1, that was step 2, that was step 3. Now we're up to step 4, which is the mole ratio. So remember I said what to do is to put your unknown on the top. So our unknown is our hydrochloric acid there. Our known is the sodium carbonate on the bottom. So we put unknown over known. And now this is where you come back to your balanced equation. Here, in front of the hydrochloric acid we have a 2. In front of the sodium carbonate, okay, we have a 1. All right, the mole ratio is for every 1 mole of sodium carbonate, we need 2 moles of hydrochloric acid. So the mole ratio is 2 over 1. That's why getting your equation is so important. So the number of moles, if we go to part 5, number of moles of our hydrochloric acid is going to be, all right, step 4, which is the mole ratio, times by step 3, 0.00208. So our number of moles is going to equal 0.00416 moles. Okay. So notice the link between them. All right. The number of moles of our unknown, the hydrochloric acid, is twice the number of moles of our sodium carbonate, which is what we'd expect because it's a 1 to 2 ratio from the equation. Now we can go to the final bit, which is answering the question, which is getting our concentration of hydrochloric acid. So coming back to our little triangle, concentration is number of moles over volume. So it's 0.00416 divided by our volume, which we come back up here. Remember to convert it into litres, 0.0316. Okay? And we get a concentration of 0.132 moles per litre. Okay? And that is a very, very simple titration calculation. Okay? There's no other way to say it other than practice. Okay? It's exactly the same process all the way through. So if I was to show you a different equation, okay, a different reaction, I'd be doing the exact same steps. It would just be different numbers. So your best use of your time now is to go and try some. Okay? Practice those questions, come back and look at the video, but follow that. Step 1, balanced equation. Step 2, write down what you know. Step 3, calculate number of moles of your known, and that's the one you've got 2 values for. Alright, then calculate your mole ratio using the equation. Then calculate the number of moles of your unknown by timesing step 3 by step 4. Okay, then calculate whatever's asking you to do. That's all you've got to do every time. Go away, practice, ask me if there's any questions. Thanks, guys.